Okay, I'm going to say something controversial. This Department of Energy report that came out in July called I claim concludes and finds that immediate and aggressive action is imperative regarding climate change. Now, how could I possibly say that? The authors wouldn't say that themselves. But let me explain and defend myself. So, a little bit of a background on this report. There was this critical review of the impacts of greenhouse gas on the U.S. climate. Of course, everything in climate change, we have to use too many words. It was 141 pages, and the authors, some of which I like, did a good job of pulling this thing together in a month or two. And they did what you would have to do if you were to pull together a report like this in a month or two, which is kind of dust off and refresh your existing work, and publish it. That's all they had time to do. And the five people dusted off their kind of climate skeptic work and repurposed it in this report. And very predictably, a lot of people commented on the report. I commented on the report. And so did 60,000 other people. I have looked at the experts' comments. I looked at what experts were saying before they commented, and I looked at what experts said after they commented. And uh, there's this professor who I think does a pretty good job. Andrew Dressler is at Texas A&M, and he put together 60 experts, and they wrote a report and commented. And they called their comments the Climate Experts Review of the DOE Climate Working Group report. I call it the experts review. I call them the experts. I call the working group, the DOE Climate Working Group, the five authors, I call them the group. Sometimes I call them the unsettled. Because they claim this climate change issue is unsettled. It's a direct quote. One of the guys wrote a book about that called Unsettled. The experts review was 459 pages. Now, there's no way really to have a public conversation about 141 pages or 459 pages. And I think that's a lot about what's wrong about this climate change discussion. The other thing is there's really no way to have a conversation about climate change or energy policy, people calling each other names. I talk to people all the time about climate change who I know disagree with me. And I got to tell you, by and large, they're very well educated, they're very smart, and they're very well intentioned. So it's really not the case. And I would even say that about some of these authors in this group. I mean, this is not just because they've kind of made their living on the skeptic side of the discussion. It doesn't mean they're bad people at all. In fact, the one that I know the best is a pretty good person, and is certainly very very bright and very knowledgeable about the issue. So I am trying to turn this into a tweet, and my tweet is, just to repeat, this Department of Energy report on the climate finds that immediate, aggressive, direct quote, action is imperative, direct quote, to protect the Earth from disastrous climate change impact. Now, the authors would say I'm misquoting them. I claim I'm not. So when you go try to distill 141 pages down to one thing you can talk about, I would refer people to the DOE report, page 25. and specifically section 4.1. And I would specifically refer people to the quote. This is a direct quote. If the ECS is very high, above 4.5 degrees C, immediate aggressive emission controls become more imperative. Direct quote. And then that author in that report goes on to explain why there's all sorts of uncertainty in this ECS. The ECS is a climate sensitivity, which I claim is just the wrong thing to talk about. I understand why people did it 40 years ago because they had to make a guess. And the guess was if you doubled the CO2 in the atmosphere from the pre-industrial benchmark, what would the climate response be? How many degrees would the Earth change? And the consensus was 3 degrees. And really, that 3 degree doesn't appear to be a bad number from the perspective of 30 or 40 years ago. I think it's clearly well over 4.5 today. And we're going to talk about that. And that's really my point. My point is we made this report with stale information. There's not a shred of information in that report that predates 5 years. And sometimes you go look at Lewis 2025, it's one of their citations. You go read, you go pull up Lewis 2025. And sure enough, he's talking about some model that's 5 or 6 years old. So even the apparent refresh is really not including any of the current data. And why is that important? Because the current data is the hot data. So I just want to make this clear. We had all these years where the climate just kind of bumped along. Sometimes it was hot and sometimes it was cold. It really didn't change very much until you get to about 1940. And so you had 100 years. Even you get to 1979 and the climate really hadn't changed yet. We keep dumping the CO2 in the air. The CO2 is going into the atmosphere. It's going into the ocean. It's going into all these places. But the climate really hadn't changed very much. You get to 2009 and the climate had changed. And around this time, people were talking about this climate sensitivity of 0.2 degrees centigrade per decade. And so really, if you look at the authors of this DOE report and their frame of reference even today, it's, hey, the climate's changing at 0.02 degrees centigrade per decade. Why bother? Why bother doing anything aggressive and costly? And I don't want to take that bait. I don't need to have that debate because then this is my point. You get to 2015 and all of a sudden the climate's not changing at 0.2 degrees per decade anymore. It's changing at 0.4. So 0.4 is twice as much as 0.2. So when it was at 0.2, when we thought that the traditional value of this climate sensitivity, this ECS, which is a nonsensical metric, was 3, at 0.4, it's the wonderful thing about arguing about the ECS because it's some nebulous thing that can't really be observed. But we can observe the temperature outside. And so what I'm saying is from 2015, the last 10 years have been the hottest 10 years in the history of Earth, hottest 10 years since humans were humans, the hottest 10 years in 125,000 years. So we are experiencing a changed Earth, one that humans have never been exposed to. I frankly think that's a little risky. So maybe we should look into this a little more. And the really kind of the knockout punch years have been the last 2 or 3 years. Like 2023, the probability of that year happening was 0.3%. 3 times out of 1,000. The probability of 2024 happening was 1 time out of 1,000. The probability that you would have um, a 1 time in 100, a 1 time in 100, a 1 time in 100, a 1, 3 in 1,000, a 1 in 1,000. The probability, the joint probability, as they might say in the math department, of that occurring is over 1 trillion to 1. In fact, it's 1 divided by 10 and 21 zeros. So it's more likely that you would go buy your lottery ticket, win it, collect your $1 billion. The next time there's $1 billion, go buy your lottery ticket and win that one too. So that's more likely than what we're seeing is natural variation here. I make this little chart. I try to make that clear. People don't like looking at charts. They don't look like looking at numbers, but more than 1 in 1 trillion probability that we're just seeing the weather here. In fact, what we're seeing is then I put the data into Excel. I come up with what I just told you. I put the data into MATLAB. The first piece of this speech, a high school kid could do. I mean, it might have to be a senior in high school in statistics class, but it's not difficult. It's just in Excel. I didn't use any particular crazy stuff. And I just asked myself, what is the probability given this 145-year-old data set? What's the probability of each of those years occurring? And the answer is what I have on the chart. So the last 10 years were all 1 in 100 years probability or down to 1 in 1,000. Now, I put the same thing into MATLAB, which is a kind of computer program for math people. And I curve fit. I could do it live. I have MATLAB live right here. I just pull it up. I can do it for you. But I assure you this is the outcome. And I ran this a couple different ways, but the curve I like the best because it's easiest to explain is this exponential curve. So this line is fitting all these dots, random, random, random. Oh, the dots are starting to go up. Oh, the only thing that's happening is these dots are going up and up and up. This curve has turned. It's never going to turn back. It's turned past the point of no return. That's what these little hash lines are saying. Those are the probability that all the future numbers are going to be within a 95% chance in between those two numbers, which is the atypical test for statistical significance. So I can sit here and say with the statistical significance that we are experiencing exponential growth in this climate. And that means that there's only one conclusion from that, which is this climate sensitivity is more than 4.5. And so I don't need to go ask like some PhD guy that runs these models or go try to convince these people who wrote this report. Oh, given the last 10 years, what do you think the ECS is? Because like I don't want to argue about it. I don't have to argue about it because the data, it used to be we had to guess what the climate was going to do. Well, the Earth spoke. While we've been trying to guess what the Earth was going to do, the Earth just did it. And it got hotter. So that's what I say here. So anybody who goes and has this conversation about climate change and just ignores the last 5 years, it doesn't even matter what they're just wasting each other's time. I would say the experts are missing the plot on this too, because they're just wedded to this flawed. I'm not saying this international process, this IPCC, this international planet, a panel on climate change isn't a good thing, and doesn't do good work. What I am saying is, it's not sufficient to explain what U.S. governmental policy should be, because these skeptics at the DOE have a point. We have a lot of oil and gas in America. And what should we do? Like we're not England, which is an island that has no natural resources. We actually have a lot of natural resources here. And and really, kind of going back to my point on just the data, um, it really wasn't particularly clear in 2015 what we should do or not. So 10 years later, it is perfectly clear. So when you go to these politicians and they took positions on this, they go back to 2012 or 10 or like it wasn't as clear as it is today. We have all these hot years, the hottest years in human history. And so, I just downloaded this data myself. I went to NASA. They have this GLB data set. I downloaded the data set. I did this analysis that I just described. And the analysis is on an Excel spreadsheet that's on my web page. Go do it yourself if you want to. But finally, some experts started saying the same thing I've been saying, which is, hey, the climate's changed. So what did this guy just say here a couple months ago, Foster 2025? He said, removing the best estimate for the influence of the three natural variability factors on the global temperature reduces the noise level of the data sufficiently to reveal a large and significant acceleration of global warming. Oh, I think it's kind of the same conclusion I came to. The most important insight from this adjusted data, I didn't adjust my data, I just used the data, and I can explain why that's a pretty good assumption, and if you really want me to, is that there's no longer any doubt regarding a recent increase in the warming rate. They conclude that the Earth is now warming at 0.4 degrees C, twice as high as the 0.2 degree per decade rate, as previously observed, and as in the minds of these DOE report writers. So my claim to the DOE report writers is you're absolutely correct. That if the Earth is warming above 4.5 degrees C in this ECS, which is a different metric than the degrees per decade. I like the degrees per decade because we know what that has been in literature too, and we know what it is now, and you can go put your hand outside and measure it. It's observable. This ECS is not observable. It's just a construct of what people want to argue about. I don't want to argue anymore. So my claim is on section 4.1, if the ECS is high, which it is, it's changed, it's doubled, immediate aggressive emission controls become more imperative. The authors made the conclusion. Now, oddly enough, the experts' response also addressed this issue in their 480-page document, and it's buried on page 95. And I'll quote, internal incoherence. The report is undetermined, is undermined by critical logic inconsistencies. A nice way of saying what I just said. It champions a climate sensitivity estimate that by its own stated policy threshold justifies the very emission controls it argues against. So like these experts are pretty smart guys too, and they picked up the same thing, but they didn't really realize it's the knockout punch. The knockout punch to climate skepticism is not arguing over what the ECS should be, or what the IPCC report 6.5 says. No one cares. It's the wrong argument to have. And, the skeptics are like, you know, a grown up playing with the cat. Like it's the easiest thing in the world to go be a skeptic against this IPCC process. Like people just have to get over defending it. Um, the knockout punch is at the current state of the climate, not a modeled state, not a predicted state, but what the Earth is telling us today. We're warming more rapidly. We're warming rapidly enough that in this DOE report requires immediate and aggressive control. So I told you what I did. I'm going to go over that in a minute, a little more. I told you that, this Foster guy agreed with me. You read his report. And then the State of the Climate 2024 was published in August 2025. And it is a couple hundred pages of just grimness after grimness after grimness. Like, I don't know how you could read that State of the Climate 2024 report and come away and not realize that our growth in this temperature rise was well in excess of this, not just 0.2, but 0.4. The last 5 years have been warming at a rate of 0.6. Like this is just getting out of control. Um, so the other thing that I hear, and like in fairness, the DOE skeptics didn't talk about this, and the experts didn't respond to this. But when I talk to people, I get, well, geez, the climate has, it's gone up and it's gone down, and that's fair. But I just want to put this in context. The climate has not gone up or gone down, to the degree we're talking about here. Here's the last 2,000 years, you know, steady Eddie. Oh, industrial revolution. Oh, well, like we're there. So no. Um, and the CO2 in the atmosphere is highly correlated to temperature. Like that's if you want me, I could change this chart to another chart. So my point is because the DOE report talks about uncertainty. Don't you know this is uncertain? The ECS, yeah, the ECS is uncertain. No question about it. Don't you know that the satellite was missing a year on one of the channels, or the sun intensity may have had more of an impact, and none of that matters. So my other kind of comment on the DOE report is they never put anything in context. So they'll say, "Oh, very alarming, the urban heat island effect." So if you have a temperature and it's in a city, part of that increase you've observed is just because the city's grown up and the pavement's turned into black asphalt and there's more concrete and there's more heat. And let me help you out. If you took all of that data and removed it from the data set, this number isn't going to change within 3 or 4 or even 5. It's noise. It's not even going to change that fourth or fifth number I had on that spreadsheet. When I go to this spreadsheet, it's got all the, 0.94. It's not going to change any of those numbers. The satellite isn't going to change any of those numbers. The sun being a little more intense isn't going to change any of those numbers. Like, they don't put what they're saying in context of, oh, well, this is a very real thing. It creates an uncertainty, and they don't quantify the uncertainty. I mean, I'm telling you, the uncertainty wouldn't even be noticeable to the fifth digit. And importantly, this curve, this exponential growth curve, wouldn't change 1 pixel. So, okay, we can talk about it all you want to, but it doesn't matter. And uh, so what do I think? I really think that this DOE report and the 60,000 comments that these 5 people are going to have to respond to. And the experts, 4,000 and 4,500, excuse me, almost 500 pages. I think it's an opportunity, okay? And I really do think if you took these 5 skeptics and you put them in a room and you said to them, I want to behave like any other science experiment that you've ever done in all of you've each been in this business for 40 years. You know how to do a science experiment. And one of the things you have to do when you have a science experiment is bridge to the initial condition, the boundary case. Where are we now? Because unless your conversation, your claim, your guess of where you're going to leap off and go, your journey down this scientific method, unless it starts from the known and existing condition, I realize this existing condition could be plus or minus some little minor twit here and there, but the plus or minus is not big. I mean, just to be really clear, that chart's pretty damn definitive right there. Like that's like that equation is just go. They need to start with MATLAB and the numbers, and both sides need to bridge their story to the boundary case. That's what you do in science. And if we did that, I assure you, we wouldn't be talking about whether the ECS was 4.5. We'd be worried about it being 5 or 5.5. And sure enough, when you go look at people who are concerned about that, they're like, don't you know that number could be over 5 right now? And I completely agree because I'm going to go pull something else up here. Because that's what this chart's saying. And so kind of getting back to the data here on what I did here, just because I want to convince everybody and make this shit up. So the first thing I did with the data was I like put it in a linear curve. And sure enough, if you put it in a linear curve, you're like, oh, well, we're at 0.2 degrees per decade. What are you worried about? Well, we're not experiencing linear growth. And then we are experiencing exponential growth. That's this curve here. I tried a few other curves. I didn't like them, so I kind of abandoned the other curves. And then here's kind of what I did to start off with. I just looked at every year and the January through December, that's the annual temperature anomaly. And I kind of after the end of every decade, I paused. And what I kind of came up with was, a lot of these decades look like the previous decade, and inside the decade, things really didn't change very much. And the last year we had a normal year, kind of like where would you be on the bell curve, if you will, was 1978. It's kind of a cold year in my recollection, 78 and 79. One of those years the Bengals were in the Super Bowl. It was the Freezer Bowl. I think that was 79. I was freezing second coldest game in NFL history. I was in the nosebleed seats freezing. Yeah, and that's kind of average. But then we just started to blip up. And we haven't had anything within a 90% probability of occurring since 1998. That's a long time ago. And so you can see here, like green is cold, and well, we just went to red, and then we just went off the charts. So like for anybody that knows statistics, 2020, um, four was three standard deviations from the average of this period. So what I'm saying is, it's just math, that if you have a three standard deviation year and a 2.8 and a 2 and a 1.9 and a 2.3 and a 2.3 and a 1 point or 2.0, and the chance of all that happening jointly in a row is 1 to the 10 to the negative 21st. In the math department, they call that almost surely zero. So, this is my defense of my outrageous claim, purposely outrageous claim. And I'm kind of standing by my position, which is corroborated now by other more qualified people than myself to do and publish this math. So as I look at the other kind of thing, and I just got to say this before I end, is that there's this premise that the cure for climate change, electrifying the industry and transportation and using renewable energy and all these things. The premise is that's expensive. It's not true at all. As we sit here today, half of the United States of America, everything from Texas to the West, is 40 to 50% of the power already comes from renewable energy. Our renewable resources, our renewable energy resources of wind and flat land to put these solar plants on, sunny land, our renewable resources here in America are really every bit as important as every other one of our other natural resources. And the only thing that's happened when we've had half of the country go to half renewable energy is the price have come down and the reliability has gone up. Iowa's 83% wind. North and South Dakota, about 60% wind each. Colorado's 40% wind. Texas was a very big market, so it's a percent of a huge number, is 40% wind and solar. You go back 2 years where that number was lower, maybe 19, 18%. The power price was $71. In 2024, it was $34. That's $18 billion was saved by wind and solar. And I know this is kind of hard to believe, but the reliability of these systems has improved. So the grid operators actually have to pay people money for reliability. They pay power plants to go into standby and they do all sorts of things to achieve reliability. Well, those payments in Texas have gone down $10 billion. So, and the same thing's true with California. So, like the needing to take aggressive action, it's not a bad thing to do at all. It's no more outrageous than wanting to fully develop any of our other natural resources here in America. Thanks for listening, and I do think I'm going to publish this and hopefully have to defend myself quite a bit.